Record. Okay, good afternoon, everyone. Thanks for attending today's webinar on the IRC. This webinar will be recorded, and the recording it will be posted on the Colorado Energy Office's Code Adoption Toolkit. If there are any issues with audio, feel free to write me in the chat. My name is Erica DeLillo, and I'm a project manager for Noresco. So this series is sponsored by the Colorado Energy Office with today's training materials created by Glenn Matthewson. So let's see, we've got a few more webinars in the docket after today. We've got another one next week on building science for residential, and then we've got commercial, and then performance verification built for the building envelope. Now, I would like to mention that we will be adding more to this webinar series. This is just the initial few, but these trainings will be going on at least through June, if not longer. And then if you have a group or a specific topic that you want to hear about, let me know. Just shoot me an email. You guys have probably received emails from me before, but if not, my email's on the screen right now, and we can get something set up for your specific group that's a little bit more tailored. As most of you know, the Code Adoption Toolkit has a whole bunch of different resources on there, including all the previous recordings from trainings. Definitely check that out. But the item that I want to highlight today is the helpline. It's here to help anyone in Colorado on any of the I codes or REACH codes. So for example, if you're a jurisdiction and need assistance on a plan review, or a homeowner or engineer with a question about code applicability, go ahead and submit that question, and subject matter expert will get back to you in just a few days' time. And you can access this helpline through the Code Adoption Toolkit, or I'll post the link in the chat as when Glenn starts up. So I'm going to go ahead and stop sharing my screen. But first, just a couple of ground rules. We want to encourage questions, so please use that Q&A function. I'll let Glenn know at the end of the presentation so that we can make sure we get through all the content. There's also the ability to raise your hand and ask a question, and I can unmute you. And then lastly, there's a survey window that pops up following this webinar. If you could please take a moment to fill that out, that'll help us to continue to improve on these. So with that, today's presenter is Glenn Matthewson, and he's the founder of Building Code College. And Glenn, I will let you take it from here.
All right, thank you, Erica. Give me a second to get the screen share set up.
No problem.
Okay. All right. Well, here we go. Pretty exciting. I have put together this brand new presentation for you guys today. So you're my test ride for today. I wouldn't call you test dummies. That'd be rude. But we're going to give this a roll and see how I did here. This is like I say, a brand new presentation where I'm going to be talking to you about IRC Chapter 11, and basically kind of a general review of this. For some of you folks, you might be like, oh my gosh, this is so basic. I already have heard all this before. But hey, you maybe haven't heard me present it. And all different educators and presenters, we have different ways of presenting and providing information. So maybe I'll spin it a little bit different in a way yet you haven't heard before. But otherwise, I'm going to step you through Chapter 11 of the IRC. And again, this is sort of a kickoff for what could then lead to obviously much more in-depth education. You could do a 2-3 day class on Chapter 11 alone if one wanted to. So as Erica mentioned, my name is Glenn Matthewson. I'm really excited to be a part of this team with the Colorado Energy Office and with Noresco. They've been doing this service to Colorado professionals for quite a while, but I've just recently joined this team, so I'm excited to get to, like I say, provide sort of my flavor and my style of teaching, and hope that it can benefit you folks. This is kind of my collage of my career, I guess, and I'll just briefly mention a few things, just so you know who you're going to be spending the next hour with. I started in construction about 27 years ago as a laborer, 19 years old. I mean, I think that's as bottom of the barrel as you can get on the construction site. And I just always like to say construction's such it's like one of the best choices I made in my life because it can just open you up to so many different journeys and pathways. And this is sort of a collage of my pathway. Started as a laborer. I became a framing contractor or a framer, framing homes, got into building decks and doing basement finish, had my own residential remodeling company. 2005, I started working for the city of Westminster, Colorado. That's where I spent 13 years doing plan review and inspection. Within a couple years of working for Westminster, I started teaching and doing teaching on the side, basically, on top of that job back in '07. Writing about code, teaching about code. I write the column for Fine Home Building magazine in every edition called Know the Code. Again, I've created buildingcodecollege.com, which is an online continuing education website, just a way to reach more people. I write for ICC. I attend the code hearings because, hey, I have opinions about code. You have opinions about code. There's a place to share those opinions, and we can contribute to the future of code, the code hearings, and everybody is welcome to those. And I encourage everybody to be involved with that and let your voice and opinions be heard. Master code professional, and I was awarded Educator of the Year, which was pretty cool back in 2021 for just a self-employed independent teacher. If you want to learn more about me, knock yourself out, you can go to glennmathewson.com. There's an online bio there, as well as links to my social media and my YouTube with some additional content for you guys. All right, enough of that. This presentation is like most of my webinar presentations. I do not try to band-aid an in-person class. If we were all sitting together in a classroom, this is going to be a completely different learning and teaching environment. But I don't believe we should try to just take that experience and put it online. We just can't do it. So my style for teaching these webinars is really basically a performance. I welcome you guys' questions. I have the chat box and Q&A box open on the side, but I am prepared to basically deliver to you for the next 50 minutes or hour, whatever we had here today. So that's the style. And I mentioned this, I brought this slide up, not realizing Erica would already. Of course, you can reach out and ask any questions you want at any time to the group of code folks that can help you out at this coloradocodes.happyfox. And of course, at the end of this webinar, I'll give you my email, and you can also just reach out to me direct with specific questions from this webinar. All right, so let's get going. That was a long enough intro, and we only got 60 minutes together. Now, only like 51 now. All right, so dwellings. This is my favorite thing. This is like my specialty in teaching codes is dwelling construction, single family construction. It touches every single one of us in this country. Even if we don't have a single family home of our own, we certainly have experience with occupying them. And we've been building homes for a long time, right? I mean, this is a picture from Ominous Forks, Colorado. It's one of our ghost towns down there in the San Juan Mountains. You can see my wife and kids up there. I just got an life insurance policy on them. So I was like, go up there, let me take the picture. No, just kidding. But we did what we had to do to build homes. We cut down trees and we put them together, and we learned a lot of what not to do and what to do through what is empirical experience. Basically, we didn't research it. We didn't engineer it. We just kind of built it. And if it worked, hey, we did something good. And if it didn't work, we tweaked it and, adjusted it. But those were the old days. That's way up here in an old mining town. Obviously, as modern times moved along and we get into cities and civilization, we have to have more structure. And so building codes of the early building codes were not very user-friendly to just the average American wanting to build that American dream and build their home. And so in the early 1930s, you started getting documents coming out to help just guide dwelling house construction only, a simplified building code just for homes, because that big full-size building code, well, that's way more than you need for just a house. And that moved along in time, and around the 1970s, you started to get a big call from the architects and the contractors across the United States. At this time, we had four different code organizations writing different codes all across the US, but we were becoming a more nationalized country where builders are building across the country. And so there was a big push and demand to say, we need a unified code, a single code, a simple code for building homes. And the first edition of that was 1971. And again, I'll spare you the history here. I just got to build up a little bit of understanding to this whole chapter 11. 1972, those three organizations merged into CABO, Council of American Building Officials, and they continued to publish this 1 and 2 family code. You can see here the CABO logo now on the 1979 edition. And this included plumbing and mechanical. It didn't include electrical code from NFPA until about the 1990s. And what they were trying to do here is, again, just create a recipe book, right? Like, there's chefs that can build the most amazing, immaculate meals for dinner that the common folks we could never touch. But every one of us is able to pick up that Better Homes and Garden cookbook and make a safe meal for our family, a basic like green bean casserole. And that was the motivation and idea behind this 1 and 2 family code. Let's give Americans a way to build green bean casserole homes for themselves in a very simple and affordable recipe. And this is where we get the minimum standards. Well, that recipe, like I say, started with building, plumbing, mechanical. In the 90s, we got electrical added to it. And energy. Energy code has been around since 1976. This is when the federal government started the Energy Policy and Conservation Act, started providing tons of funding to states to help increase energy efficiency in buildings. And we're still seeing all that funding today. That funding is what's funding this webinar right now today. And this has all been going on since 1976. And in that time, they reached out to CABO to say, develop us a model energy code. This was the federal government, because they have no authority over codes. So they reached out to CABO and said, hey, you guys are the Council of American Building Officials, give us a model energy code, and we're going to help fund it and help make this happen. But here's the thing. It was always a standalone book. All of the governments around here were adopting codes and plumbing codes and mechanical codes all across the US. And suddenly there's this new energy code thing. But it's kind of like this over here, this other little thing. So, it's always easy to ignore something that's not right in your face, right? So we didn't see the US make this massive mainstream movement towards energy code, but we did start to see that happen around the turn of the century. And there's, I believe, a big reason for that is the first International Residential Code, IRC, CABO, now sort of merging or forming into what we have today, ICC. The 2000 IRC is the first time energy codes are now front and center, right there, just as important as plumbing, mechanical, electrical, building. In the same book, we finally get one book, one recipe that'll cover all of these features of construction. And so there we go. That's where we are today. And that is what the IRC is today. It is just the basic American cookbook for us to go make green bean casserole homes. And energy is a part of that. Now, we can blow up energy into a massively technical subject. You've got an entire standalone energy code book. Can't remember how many pages it is, but it's a big standalone book. So just like in the 1970s, anyone familiar with home construction and codes for home building, they're familiar with that IRC. That's the book, that's the recipe book. It's got everything we need in it. And now we see, we've been for a while in this big movement towards better energy efficiency in our buildings. And it's like, oh, hey, there's this whole other book over here for you to look at. Well, that's just as overwhelming to folks as it was back in the 70s, folks that are focused on residential construction. So that's what I love about this is everything you need from the IECC, the big full-size code book for energy, everything residentially is reprinted for you in Chapter 11 of the IRC. And as you can see here, the sections, the code text, the code language is the same. Is essentially the same. We now develop code in the energy code and then simply pull out and reprint it into the IRC. So you can see on the left, you've got chapter 11 starts out with an in, and then you got 1101.2 as the section number. But in parentheticals, you will get the IECC section number for that. So just a great way for folks, if you're kind of new to learning energy and your specialty is residential codes, do not open that IECC. Leave it alone. Don't overwhelm yourself. Stick with the book drop into chapter 11, and now you know how it correlates back to that larger code. All right, so let's jump into this and start kind of walking through some of these sections. And I'm trying to give a very high level overview of this. So I kind of picked and chose the parts of this that I thought were important. It doesn't mean that things left out aren't important. It's just that this is what I selected for this 60-minute webinar. So the first section is general, and that kind of is typical of a lot of the code structure. And so one thing I like to bring up here real quick to everybody, again, if you a lot of regulators, building code authorities on the line, you probably have tons of code books in your office. But for the public, codes can feel like a burden, the cost, right? It's like a barrier to entry. I have to follow these codes, but I have to pay hundreds of dollars for these. So I never forget to tell people about codes.iccsafe.org. That's the International Code Council's website. They hold the copyright to the codes. They invest the incredible amount of work and money in running the development process for codes. I respect that they are their codes. There are other providers online where you can find reprinted versions of iCodes, and I don't recommend those providers. I recommend go straight to the source. This is free viewing of the iCodes all the way back to the 2000 edition. So let's start. One of the most important parts to understand anytime you start looking at a code is what is the intent of this code. If you just jump right into the technical provisions and the section numbers of the code, as you interpret the meaning of those code requirements, you may not have the right basis for interpretation. And the basis for your interpretation always needs to come back to intent. What is the intent and the purpose of this code? And from that, you can then interpret the rest of the provisions. So we'll take a quick minute and talk about a few things here. This first statement says the chapter regulates the design and construction of buildings. And just a general education thing, again, I always mention in my classes, if you see a word in italics in the code, it means that that has a definition defined in the code. And we want to use the special definition in the code, not the general definition out there in society. But do understand sometimes the words are not shown in italics. You still would use the definition for it. It's actually, there's an editorial issue with the iCodes that I hope will be fixed in 2024. So just something to keep in mind. So we see buildings. Buildings is in italics, and that's the first thing we should probably just double check and be sure we know what is this actually regulating, this chapter 11. And so we also get in section 1, the general section, the definitions. Now you notice here in parentheses, it's section R202 for the energy code, the full-size energy code. In all of the iCodes, chapter 2 is the chapter that has all of the definitions. And definitions in chapters, by the way, or in codes, goes back to the 1800s. I am a vintage code collector and historian, and the concept of defined terms in codes has been around, again, for centuries. But when you have situations like the energy code, chapter 11, the fuel gas, chapter 24, and the electrical chapters, those are specific chapters of the IRC that come from larger code versions, like I've shown you with chapter 11 in the energy code. And in those cases, you're going to find some additional defined terms. So IRC chapter 2 definitions, but be sure you get those additional definitions you're going to find in section 1, section 1101 of chapter 11. So jumping into that defined term, obviously we see building is a defined term. And you know that it almost seems kind of silly, like really, do I really need you to define that for me? But this is where you see the importance of why iCodes have definitions, because no, we don't want to just use the common everyday understanding of that term. So a building, right? This is a residential code, obviously single family house. But notice it didn't say single family house. It didn't say dwelling. It says the regulation, design, and construction of buildings. That means, what about the pool house, right? So you got a pool house on the site with the single family home. You have a detached accessory structure, a garage, a workshop, right? Is it a building? It's going to fall under the provisions of chapter 11. It goes on to say, though, it's beyond just buildings, right? It's also mechanical systems, service water heating systems, and electrical power and lighting systems that are located on the building site. So also energy that's used on the building site. And if you notice the last bit of that statement, it says, and supporting the building. And this is where it's fun. You know, I'm never afraid to sometimes pick on code a little bit. The code's not perfect. It's written by humans. We revise it every 3 years because we want to make it modern, keep up with expectations of society, but we also want to make it more easy to interpret and more consistent to interpret. So I think this is funny. If you follow the path, it says it regulates buildings. Here's the definition for buildings, and it's all of these things supporting the building. Well, what about that swimming pool? What if that's a heated swimming pool? Well, as we'll find, I'll brief mention of it, but yes, we have efficiency provisions for heated swimming pools that are in this code, but, not perfectly given to us in this definition because that's not really supporting the building, right? And this is one of those times I like to say the words of the code are where we start, but the intent of the code, understanding, look, the words are the best they're going to be. If we understand the intent, we can help sometimes fill in the blanks where the words don't make sense. So obviously, we are going to deal with pool regulations for energy that's used, even if it's not, perfectly in the words here based on the definition. Anyway, another thing I want to go on and make sure I clarify or really drill down for you folks is this next sentence. It says, what are we doing? We're regulating design and construction of buildings for a specific thing, for the effective use and conservation of energy. That's the intent, use and conservation of energy. Okay, so effective use of energy, how might we regulate that, right? Well, we want to effectively use it. Here's a ventilation appliance, an HRV for whole house ventilation. And as you can see, just this little clip of code we have in this table here, we have a minimum efficacy for that fan. We have to be able to push a minimum amount of CFMs per watt of energy. That's effective use of energy. Now, notice it doesn't say efficiency, right? I just like to talk a little bit about that sometimes. Efficacy, what a word we don't hear used very often. But efficacy has no opinion to it, right? Efficiency is opinionated. Hey, take the most efficient route to work today. What that means to you might mean something different to me. It might be something different if it's snowing or if it's rush hour traffic. So efficiency isn't a word the code likes to use when we're trying to drill down this effective use. This is where we get the term efficacy, right? There's not an opinion. You may think that's efficient. You may not think that's efficient. Doesn't matter. It is how much performance you get based on a measurable amount of energy usage. So this is one way that the code would regulate effective use of energy. Other things might be like distribution systems for your air distribution system, so that it most effectively distributes that energy. What about conservation of energy, the other intent of Chapter 11? Okay, we want to conserve it. Wherever we're putting this energy, we want to keep it there. We want to conserve it in that place. So if it's cold outside and we're using energy to warm inside, we want to conserve that inside. We don't want to let it leak and get to the outside. And then that's the same for the summertime, right? Where we're using energy to cool inside the house. And so we want to conserve that energy. And then this is where we also come back to effective use of energy, right? If we're having to create heat energy or cooling to remove heat energy, we want to be effective with the appliances that are doing that. Now, there's a reason I went through all this. Is the intent of the energy code to reduce energy use? Well, what did we see in the intent? The intent was to effectively use it and to conserve it. But does that mean that the goal is to reduce energy usage? Well, let's think about that for a little bit. Here's 1,000 square foot home, and this 1,000 square foot home will need to have certain efficacies of the appliances in there, right? So that we don't use too much energy in order to ventilate the house. Effective use of the energy. And we're going to have a certain requirement in the building thermal envelope here so that we conserve the energy inside this thermal envelope. So we've effectively used it and we've conserved it within this 1,000 square foot house. But what about a 10,000 square foot house? Same thing, right? We're going to simply effectively use, but now I might have 10 ventilators. And now I might have, I have obviously much more area of house. So am I going to be using a lot more energy? Absolutely. I can use an unlimited amount of energy. The IRC will let me build 1,000,000 square foot house. I could have 100 outdoor heated pools. So no, that's the interesting part. No, the energy code is not guiding us to reducing energy use. It's guiding us to say, hey, whatever you're going to use, however big your house, whatever your luxuries are, you need to be thoughtful about it. You need to conserve it and you need to effectively use it. So again, just something I like to get folks thinking about these codes and how they apply. All right, so other stuff we get in the general section, right? How we conserve energy is going to be different based on the delta T, right? The difference in temperature difference between outside and inside, how much energy we're having to produce and how fast that energy is moving through our thermal envelope. So climate zones matter. Now, this is a Colorado presentation, so we can just box in Colorado right here. And the real quick thing we can see is we're all on the dry side. You see that big vertical-ish black line? On the left side of that, the western part of the country, there's our dry climate zones, and all of Colorado would be dry. But you can see the patchwork of colors in there. So obviously we have some variety in our climate. And if we zoom in to look at this, we've got 4B, climate zone 4 down here in the corner. We've got 5B in the eastern plains and on the western slope over there. Then we got a couple 6Bs mixed in. I'm guessing we're probably going up in elevation. It seems like a reasonable guess for those of you that know the geography of Colorado, right? And then, of course, 7. And I'll bet you can almost probably follow the Continental Divide running around that and all of our mountain ranges. So as we can see, Colorado's got a very diverse climate, and it's going to be important for you guys to look at what climate zone you're in. However, what you'll find is 4B, you guys are sort of the outliers. A lot of the provisions are the same from 5 to 6 to 7. But you 4B folks down there, you guys have some extra little special stuff that might be different for you. So keep that in mind. Now, if you don't like maps, the Chapter 11 also provides pages and pages and pages of climate zones for each county. And obviously, 2 different ways to look at it. And look at this, we're halfway through Chapter 11 already. It's about 64 pages, and about half of those pages is all just maps and then pages and pages of this climate data. So we took that massive energy code, that big, 3/4 inch binding of that code book, and we've reduced it now to under 40 pages of information. Much easier for residential professionals. So, of course, you've got to communicate with your building department. One thing I love about the IRC is it's not just one recipe. It doesn't just say, hey, if you're going to feed your family, everyone eats green bean casserole. No, the IRC is literally like that cookbook, full of choices and options and alternatives. You want to use butter, you want to use lard, you can adjust and adapt it for yourself. But what your building department is going to do for the public, like this interaction between our free public that gets to pick whatever recipe they want, whatever works best for them. And the communication to our building departments, our building authorities in Colorado, they're there to have your back. They want to get you started off on the right foot so that you're going to go into this endeavor with a good understanding of your recipe. Well, what is that going to mean? It's going to mean communication between each other, okay? So Chapter 1 or Chapter 11, first section gives us this great list of, hey, here's some of the things we're going to need for communication, guys. And if there's any member of the public on this line today, please, communication. That is where most things fall apart. Plan review is the most important inspection of the entire project because you get to fix things just with the click of your computer or an eraser. Okay, so this is a good little layout of the things. If you're going to have all this choice in code and you get to pick your own recipes, then you need to be sure you've communicated that recipe and the choices you make to your building department. And this section provides you some guidance on that. Now, this is one of my little ha-ha pictures. I didn't segue that joke, but I usually make a joke about here. This is how often the public feels. Like, okay, I've got my plan set ready for this 1,000-square-foot home. I'll bring it to you in the truck. And we're all meant to kind of chuckle and understand that feeling. But all it is communication, right? If you want to make more free choices, that means there's going to require more communication to the people that have your back to help you execute those choices well, public to building department. Now, one of the big things here is the energy compliance path, and that's what hopefully I'll briefly mention on as I go through this presentation today is, what are you making for dinner? Green bean casserole, or are you making carrot souffle? Because the code is simply saying, feed the family, right? Create an energy efficient building. So you need to let your building department know which energy compliance path did you use, because that will set you off on entirely different recipes to get to that final end product of the home. And so in the first section, general, it kind of lays out for you these various compliance pathways that I'll briefly go over. And then the new thing that came in 2021, which is our additional energy efficiency pathways. So again, the general section laying out a lot of this general stuff, definitions, intent, pathways to compliance. All right. So we're going to move along over here to the next section, 1102, the building thermal envelope. And I mean, this was probably, I would say, one of the original core parts of energy conservation, right, of our homes. This is all about conserving that energy. Here's a nice little just, stock photo image I got off the internet. And I say nice because the way the coloring of this works, or the lighting of it, actually kind of speaks a little to what I'm going to show. The building thermal envelope. If you look at this picture, we could probably just guess by the coloring, right? There's the nice, shiny, beautiful, clean parts of the house. This might be the building thermal envelope. I say might be because it's up to you. You pick the recipe. You pick how you want to build this thing, and then communicate that to your building department so they know what's happening. So what we have here in the building thermal envelope is we are enclosing conditioned space. And look at that, there's that definition. I almost said chapter 2 definition, but because we're in chapter 11, this is just in section 1101. Typically, though, again, we go to chapter 2 for definitions. So conditioned space, you can read this on your own. The thing I want to highlight here is if it's a directly heated or cooled, or indirectly heated or cooled. And so we can basically just see this is all about, are we using energy to heat or cool the space inside? And then what we want to do is conserve it in that space. But it's also indirect. So look at this basement, for example. If there is no insulation in that floor below those shiny kitchen tiles there, then that basement is indirectly heated because it's not outside of the building thermal envelope, because, hey, that yellow line of our building thermal envelope, no, that's all the way around the basement. They've insulated the basement walls. That's a choice the builder gets to make. Or maybe it's a crawl space and they've gone with an unvented crawl space design, a choice for vapor management. And then the code will follow with a recipe. Okay, that attic doesn't look very conditioned, but this is just a silly little illustration. Maybe they want to go with a habitable attic, or maybe an unvented attic assembly for vapor management. Your choices in vapor management have a direct relationship to choices in building thermal envelope and energy and the energy compliance. So you get to pick your thermal envelope where you'd like it to go. Now we jump into 1102. Now we're into that second section of chapter 11. And it talks about the building thermal envelope and that it's going to need to comply with insulation provisions. But we get 2 exceptions I like to point out real quick. Low energy buildings. That's not really what I'm focusing this discussion on. We can see some about the design rate of energy per square foot of floor area, saying, all right, if you're putting a minor amount of energy here, the code's like, we're not going to make a big deal about that. But then you get this other part of our exception that says, okay, spaces that don't contain conditioned space. If we're not heating or cooling the space, we have no need to conserve the energy in that space. So I like to bring up this example. This is a garage being built, and here's this patio cover between the house and the garage. Well, the builder that was building this patio cover, the owner decided to insulate it. Why? I don't know. They wanted to. Maybe because they didn't want the sun coming down in the summertime to heat up and pass right through and create a hot space underneath there. Who knows? If this is an open patio cover, which it is right now, then it's not a conditioned space. And therefore, it does not fall under the purview of the intent of Chapter 11. And so if someone wants to insulate this roof above, that's just on their own. They don't have to reach any insulation levels. They don't have to follow any of the code compliance requirements because it's not a conditioned space. But anytime, this is my advice now to you regulators out there, if you have someone come to you with a design like this, communication goes both ways, my friends. We want the public to communicate and give us all the information of what they're doing so we can help them and have their back. But sometimes helping them and having the back of our public, of our communities, is kind of sometimes foreshadowing what might they be thinking, maybe asking the right questions. For example, you may ask the person, hey, are you insulated? Why are you insulated? Are you insulating this because maybe next year you're planning on enclosing it and maybe making an addition? Do you have a future plan for this? Hey, let's talk about that now so we can get you off on the right foot. Or maybe they say, no, I have no intention of ever enclosing that. I just figured why not fill the cavity with insulation? Makes sense. It can't fill it later. Okay, great. And then we go from there. What might be another example of this? Garages. This comes up all the time. I bring this picture up when I talk about drywall protection for fire protection of garages. And I say, hey, sometimes you have to drywall an exterior wall of a garage for fire protection. Wouldn't that be a great time for the homeowner if they wanted to throw some insulation in there? Not because they're going to heat the garage or create a conditioned space, but they just want to take the edge off a little bit, right? They just want to, conserve a little bit of the heat that just naturally is in their garage. Nothing wrong with that. If it's not a conditioned space, again, no requirements for how much insulation they put in there if they choose to put some in. But excellent opportunity for the building authority to be a partner with their community and say, hey, if you are going to be insulating that and later you plan on putting a unit heater or something to turn this into a heated garage, you may want to do XYZ to prepare for that future plan. And then your public starts to see the real value in what you can provide them. Just some little tidbits about working with your public and understanding the limitations of when the intent of the energy code applies and when it doesn't. So other thing you get in section 2 for the building thermal envelope is basically your cookbook recipe. These are some clips here that the insulation and fenestration criteria, R value alternative, and R value computation. These are just your code sections here for that prescriptive basic recipe for the building thermal envelope. And we'll get into some of the other alternative compliance methods in just a moment. All right, so that's what we get in 1102. And what else do we get here? We get another section, or excuse me, that was 1102.1 for general building thermal envelope stuff. And now we're in 1102.2, where we get this section on specific insulation requirements. Now, this has two kind of purposes. First of all, within this section, the first couple subsections of this are some very specific allowances for some reductions and some alterations in the insulation requirements only for the prescriptive path. And the entire purpose of that is to continue to allow conventional wood frame construction, right? We go back to the 1970s and go back to the past where we weren't using trusses, prefabricated engineered trusses as commonly. People are framing with conventional lumber, 2x10s, 2x12s. We have all the provisions in the IRC for conventional roof framing still today, because we still want to be able to provide that cookbook for folks to just buy a bunch of dimensional lumber, no engineering required, basic commodity products, and assemble human shelter for themselves. But guess what? In this time, we've pushed energy conservation so much higher that the conventional wood frame construction methods don't generally have enough volume to provide the R value of insulation that we're expecting in more modern times. And so we have this weird little bit of history kind of clinging on in the energy code still today, where we still allow a method to build with dimensional lumber and no engineered materials, engineered trusses, etc. And that's where we get some very specific allowances, I'd say, to allow for that. But what you mostly find in this 1102.2 subsection about specific insulation requirements is all kinds of guidance on the interaction between insulation and other features and components of the building. Okay, for example, insulation baffles, right? Okay, insulation is going to have an interface with ventilation that needs to come through that soffit ventilation, if that's the design someone selected. Okay, that's an interface. Where would I find information, specific details about an interface with insulation and venting? Oh, 1102.2 in those specific criteria. What else might be something like that? Oh, the attic insulation and its interface with the attic access opening. Oh, well, there's an interface between insulation and another construction feature. Where do we find those details for that? The specific criteria, 1102.2. What about access hatches and doors? The door itself now, right? That's just about the retaining baffle so that that insulation doesn't fall into the hole. But what about the interaction now of that we've created a hole in the insulation for that access door? So we get another little section that gives us that added guidance. Okay, here's how you handle access hatches and doors, right? And so that's where if like you look at this access hatch to this attic, that's a big hole in the insulation. And this section is saying that's not an effective use, or that's not a good conservation of energy, right? You have a hole in it. So we're going to need you to insulate that in accordance with the table for your insulation values. But here's where I'm going to bring something up for you guys in that 4B climate zone. This is where if you want to do a drop down ladder like this, this isn't a this photo is technically a garage, but pretend this isn't a garage and we're inside the conditioned space. This is going to be a little more difficult for you in our Colorado climate zones because you've got to replace the insulation that's missing there. However, we do get an exception to that provision for folding ladder access hatches like that. And you guys, if there's any of you online down there in our southeast corner of Colorado, well, this is where you get a little special treatment. Okay, you're not quite as cold down there as the rest of us, and there's an exception to allow you to use those ladders. So I chose to bring that up in this class because it speaks to one little outlier part of Colorado there. All right. Well, now let's say we do decide to heat that garage. Well, we're going to heat the garage now. We decide to do that. Are there going to be some other specific insulation criteria or more specific details? We're not just heating the house, the conditioned space where you're going to heat it constantly with a thermostat all day long, even when you're out of town, even when you're at work, even when you're sleeping at night, it's running on its own. Is that generally what we do in garages? Well, no. Human behavior in garages is usually a little different. It's usually point of moment of heating, right? You're going to go out there to the garage, you'll turn your unit heater on. Rarely do we see, it's not as probable in American culture that we have a thermostatically controlled, fully heated garage all the time. And since that's not what's really probable, it's just possible. We don't really write codes to that. And here's where I'll bring up one of my little quotes I always say in my classes. Code is about what's probable, not what's possible. And so what's more probable is a unit heater like this in a garage, and therefore that's what we developed the code to address. And so you get specifics, you get a little different rules for sunrooms and heated garages, and we find that in 1102.2. You get specifics for floors, right? How much insulation goes in the floor? Well, you find that based on your compliance pathway. But how do you install it? Well, that's where you're going to go to those specific insulation criteria. And I want to point this one out for the members of the public on the line. Check out how this starts out. Floor cavities shall comply with one of the following. What does that sound like to me? That sounds like a free choice. That sounds like pick your recipe. But hey, guys, once you pick that recipe for how you want to build, what do you got to do? What do you got to do? You got to communicate effectively and well to the people that got your back. Your building authority, that's going to help you execute that the way the code would like you to and get to the performance the code is looking for. So always love to let folks know when those choices are there. And since I'm guessing it's majority code authorities probably on this webinar, I want to remind you guys of that as well. Not all choices are for you to make. Sometimes the best course of action to serve your community is to be sure to let your community know, hey, you have a say in this. If you don't like the result of your choice, did you know? There's other choices. And then I'll bring you different results in my evaluation. So remember that as well. All right, what else might we get? Basement walls, right? Specific rules for insulating basement walls. But remember at the beginning of this presentation when I was talking about defining the building thermal envelope, maybe you don't want the basement within the building thermal envelope. Well, if you look at the exception here, there's all this listed criteria to say, okay, that's your free choice to make. Now the code's going to give you criteria to follow, a recipe to follow based on what you'd like to make. All right, so you can see that here. We have the exception, basement walls that are unconditioned basements. Not as typical. Typically, the basement becomes part of the conditioned space, part of the thermal envelope. But hey, That's not for the regulators to say. That's for the person picking the recipe. And we got a floor in here, right? Slab on grade floor. That's another element of the building thermal envelope that we need to make sure we're conserving energy through. And this is where we're going to find the specifics for it. Crawl space walls, this is where we find the specifics for it. 1102.2. All of that interface and all of those specific requirements for our different little elements of the thermal envelope. All right, what else have we got? Now we're on to the next subsection, 1102.3, fenestration. I tell you, that's a word I never heard until I got into code. But basically, right, what does it mean? Windows and doors, essentially. So if we're looking at this picture here, we've got fixed windows, we've got operable windows, we've got the door. These are fenestrations. Now you might be thinking, hey, hold on, Glenn. Dude, you already talked about doors. You showed us a whole section, said access, hatches, and doors. See, words in a book, doors. So I guess I have to insulate the door to the full R value of the table. No, because that's why the code is so complicated and so difficult sometimes and has so many things we got to read and exceptions, is because it's very specific. So this is specific. No. The title might say doors, but it's doors such as to spaces like attics and crawl spaces, like the door you see here going to the attic. This door, sure, that's an access door to the garage, but that's not similar to attics and crawl spaces. So if that door from the house to the garage is where the building thermal envelope has been defined, which most likely it is, that door is going to fall under the fenestration requirements in this section, and then I'll point us to a completely different table with different provisions. So again, that one down in the bottom corner is just more specific to that particular kind of access door to attics and crawl spaces. And then again, more and more specifics. What about a door from a heated garage? But not the door from the conditioned space within the thermal envelope out to the heated garage. What about a door from a heated garage out to the outside? What's a little different kind of door? The energy dynamics are a little different. The usage of energy inside the garage is, the probability is a little different. So the code addresses it different. The complication of the code is for the benefit of the public. The public just has to learn it and grasp it and say, yes, I get to make these choices. So let's take a look at this attached garage here. Let's say that's a heated garage. We got a heated attached garage, and I see a man door right there, right? A human door, a fenestration. Well, if that fenestration, that human door, is going into the heated garage, I'm going to go to this section of the code, and I'm going to deal with the door, the fenestration to the heated garage. But I don't know, this is just a stock photo, so it's just a training example. Maybe that door isn't into the garage. Maybe that door is actually into the conditioned space within the building thermal envelope, goes into like the living room. Well, now we're going to go back to that main subsection for fenestration, and we're going to regulate that door and look at designing that door differently. So 3 different doors. The code is not one size fits all, because that wouldn't really support a lot of American freedom and choice and how we want to build, would it? No, it wouldn't. The code is there, giving choices and options. Thermal envelope, air leakage, our next dot 4. This is our next subsection, okay? So obviously, right, insulation is just about heat moving through solid materials, through via convection and via conduction through the materials, through the air pockets of the insulation. But what about just if you open the window in the middle of winter? All your heat is quickly going to not be conserved inside the building. So air leakage is another big element to conserving energy. Of course, we have definitions for air barriers in there. And then we can go to this table in the IRC for air barrier criteria. Now, this came into the IRC in the 2012 edition. And this was before we had mandatory requirements for testing the air sealing of the building thermal envelope, like the blower door test. And what we had was this visual inspection checklist that you could go by. And this is under the subsection still today for air barriers, right? 1102.4. But I want to make sure folks realize it does extend beyond just air barriers. There's a whole column for insulation installation criteria kind of like the other subsections that gave all those specific criteria for basements and crawl spaces and retainers around attic access. This is more of that additional little specifics. And if you notice, like under walls, you get R3 per inch in here for like insulating cavities and headers. So there is definitely information here about insulation installation that's not air barrier related, but it happens to be under the air barrier section. Is that perfect? No. Is the code ever going to be perfect? No. That's why I'm mentioning to you, don't forget, we got that here. But what you do get is this nice big line here for air barrier criteria with all kinds of tips and guidance and what to do here, what to do here, how to seal this little area. And this was really critical in 2012 when we had to speak with words to say, hey, here are some things you need to do to try to make the house tighter. But now 2021 code, we've moved along and now we get maximum leakage rates that have to be tested. And for Colorado, in our climate zones, including you guys in climate zone 4 down there, it's going to be a maximum 3 air changes per hour. Okay, so in a way now that table that provides all that air barrier criteria, in a way, some folks out there like, say the code is really just a guide for construction. And in a way, that table at this point really is just kind of good advice because ultimately this is now the make or break thing. Do you meet the maximum air leakage or not? You have to prove it via a test. That table of guidance is some really good advice for how you might end up passing this test. But now is the test that matters. Hey, let's go back to that heated garage. It's one of the nuances I decided to bring up in this presentation today. It's some newer stuff we've gotten in 2021 code because it's going back to that. The code is complicated because it's so specific. We don't paint with a 4-inch wide brush. We paint with like a single horsehair, absolute fine artistic brush. And so there's exceptions for air tightness. If you have a heated garage, those garage doors are going to be really hard to get really airtight and to get that 3 air changes per hour. The nature of the garage and the nature of the garage door and the nature of a slab on grade that's not supported by a foundation that has the ability to move, the general nature of garage doors is they're going to be a little leaky. And so what do we get when we get to heated garages? Now, what does it tell us? Go back to that table and field verify. And so lo and behold, that table for 2021, where we only had this guidance for air sealing, now we do the blower door test, and this almost becomes just suggestions. And then now 2021, we go, hey, what about these heated garages? We need to do something to address these, but we can't test them. And now we see this table has some real importance and value again, that's beyond just recommended, but now it's like, no, you've got to follow these things for your garage because we're not able to test it. Moving along, we have section 1103 for systems and 1104 for electrical power and lighting. And good thing I didn't dig deep into these sections because boy, does an hour go fast. Holy moly. So we won't get through this whole presentation today, but let me get you through this little part and then I've got a few words for you. So under these sections here, this is where we get more, I would say, not into conservation of energy, but more about that effective use of energy. Okay, doesn't say how many, there's not a limit on how many furnaces you can have or a limit on how many outdoor heated pools you can have. There's no limit to size or abundance or gluttony, but once you've reached what you want, then you have to effectively use energy within those desires. So things like the controls, thermostatic controls, automatic lighting controls. You can put all the lights you want in your 100,000 square foot home. There's no reduction in energy use, but you've got to have the ability to control those lights so they're not running in the middle of the daytime when the sun is out. Things like that, right? Effective use. You get effective distribution in your ductwork and effective insulation, right? If your ductwork is inside the house versus if it's in the attic versus if it's buried in the insulation, there's guidance so that we effectively use that energy. Piping insulation. And then that gets even further discussed in another section about hot water distribution systems, right? We have to heat the water and then we're running it through these distribution systems. There's nothing stopping you from doing that. Right? It's not reducing, it's not eliminating the energy use. It's simply saying, all right, if you're going to do that, you need to be effective. about use of that energy. Mechanical ventilation, whole house mechanical ventilation, that's a huge can of worms that starts to, definitely connect with many other provisions in the code, including natural ventilation out of chapter 3. Efficacy of mechanical equipment and efficiencies of mechanical equipment. Same thing. It's not going to tell you a limit to how many of these appliances you can have and these luxuries you can have, but it's going to say those luxuries and those choices need to effectively use the energy. And here's where I mentioned that pools and spas. I found it interesting. If you follow the intent and you follow the definitions, everything seems like it has to support the building. But if you're heating your pool and spa, as well as some other energy usage of your pool and spa, that's going to fall under this section. And then snow melt controls. Again, you can use all the energy you want to melt snow off your 10,000 square foot roof up there in Aspen, Colorado, but you have to be efficient with your snow melt controls. And I should clarify, I just out of just talking, I mentioned Aspen just then. You guys all know Colorado's a home rule state. I'm showing you the residential code as a model code. We have the Colorado has adopted an energy code, but we know individual jurisdictions in Colorado can make their own changes. So I was just using Aspen as a quick example where you probably have 10,000 square foot homes with snow melt control. Anyway, okay, this is where I was going to get into now talking to you guys about the the alternative pathways. But I see that I don't do very well with timing my brand new webinars that I haven't taught before, because I got about 3 minutes left on this and a fair bit of presentation left. So what I'm going to do now is I am going to...
Hey, Glenn.
Yes.
So what we could do here is get through what you can get through today, and then we can always add another webinar for part 2, if you'd like.
Let's do that. Because
cool.
because I don't ever like rushing through my slides. I think that's just a waste of everyone's time. And with 3 minutes left, I have a significant amount left. So we'll wrap that up with this today, guys. I apologize that hey, this is how it happens with new presentations. You don't always know exactly how things are going to time out. But I will keep working on this little series. I have a lot of ideas for chapter 11 here where I really want to get reaching those professionals in residential code. A lot of you building authorities, inspectors, and plan reviewers, I know a lot of you guys maybe are really comfortable in the IRC and you're still learning and growing in the commercial, the bigger stuff. Same with designers, same with contractors. There are definitely a variety of professionals that focus in the IRC, and I want to show you guys how to use that one book most effectively for yourself. Thanks so much for spending your afternoon with me today.
Great. Thanks so much, Glenn. If there are any questions, feel free to write them in the chat or raise your hand, and we'll lob them over to Glenn. But he's a wealth of knowledge when it comes to the IRC. So any question you got, let's try and challenge him a little bit.
I love it. So let's see. Looks like does this become a conditioned attic and have to be ventilated? So I'm not sure the nature of that question. But that's going to get to a lot of your vapor control. And that's where we start to get a lot of overlap from chapter 11 into some of our other chapters. The other chapters are going to discuss ventilation, floors, walls, roofs in those individual chapters. But the ventilation recipes, choices are going to directly interrelate with similar choices in chapter 11. So I'm not sure how to answer the question there, but the main thing is the designer has to decide, is the attic within the building thermal envelope or is it not within the building thermal envelope? And then from there, there's some other choices that can be made. Is it a habitable attic? Is it not habitable, etc.?
Perfect.
Help our customers. One person mentioned they put the table with information packets to help inform our customers. And I just want to say to the person that wrote that, thank you so much for speaking to your community as your customers, understanding your position as to serve them and to help them and to assist them. So thank you for doing that. And don't see any other questions there.
Yeah, looks like we're all set. So I'm going to go ahead and stop the recording.